Good morning everyone. My name is Yogesh Phalla and I'm going to start the topic of change of order of integration. Okay. Now in our previous session or previous lecture, I have explained you to how to change the order of integration in case of a single strip. Now this is the type 2 in which we are going to divide the given area in two or more than two parts, and we have to consider more than two strips, okay, or two strips over there. So let us take an example for this one. So question is, evaluate double integral 0 to 1 x square to 2 minus of x into xy dy and dx by changing order of integration. Now from the given statement, it is clear that the values are in terms of x. Okay, so that means they are the values of y. So y is varying from x square to 2 minus of x, and x is varying from 0 to 1. Now what is y is equal to x square? Y is equal to x square is a parabola. Which category parabola? It will be an upward parabola. Okay, upward. And y is equal to 2 minus of x. This implies x plus y is equal to 2. So this is a line, okay, which is passing through the points. When I substitute x equal to 0 over here, so if I substitute x equal to 0, y will be equal to 2, okay, and when I substitute y equal to 0, so x will be equal to 2 over there. So this point is, this line intersects x-axis and y-axis at the point 0, 2 and 2, 0. Okay, so we draw a diagram for this one. Let it be x-axis, x dash, y positive and y negative over here. Okay, now the point x equal to 2, y equal to 0 is lying over here, and the point x is equal to 0 and 2 lie over here. So we join these two lines, two points like this one, and the second one was parabola, so it was an upward parabola like this one. Okay, now the limits of x from 0 to 1, that means we are working in the first quadrant only. Okay, so we need only this side area, this one. Now we have to move from parabola to the line, from parabola to line. So that means they have provided us a vertical strip P and Q. Now to change the order of integration, what we need to take horizontal strips. Okay, now the property of a strip is that both ends of the strip must touch the given curves. So we can't consider such a curve which can touch the parabola and a straight line simultaneously. Okay, so what we do, we divide the given region in two parts from the point of intersection, from this point. Okay, this one. So let it be O, this will be A, this will be B, and let it be L. Okay, now first aim is to calculate the coordinates of A and L. After that we'll do further process. So to find the points of intersection, to find the points of intersection. Okay, so we have it, this is our equation number 1, and this was our equation number 2. From equation 1 and 2, from equation 1 and 2, what we get two values of y. So that means x square is equal to 2 minus of x, or we can say that x square plus x minus 2 equal to 0. So we need to calculate the factors over here. So if we want to find the factors over here, so it will be x square plus 2x minus of x minus 2 equal to 0. Taking x as common, so x plus of 2 minus 1 common, x plus of 2 equal to 0. So the factors will be x minus 1 and x plus of 2 equal to 0. That means x equal to 1 and x equal to minus 2. So minus 2 is in the second quadrant, so we don't need that. So the point of intersection will be x is equal to 1. So if x is equal to 1, then substituting in any of the equation over here in equation 2 or equation 1, so y will be 1 square, that will be 1. So that means A will have coordinates 1 and 1. 1 and 1 with the point of intersection of A. Now we have to draw a perpendicular AL on the y-axis. So in that case, on y-axis, x is always 0 and the coordinate of y will be 1 over here, and coordinates of B are 0 and 2. Okay, now we will divide the required region. What is the region? OAB, okay, in two parts, that is OAL and ABL, such that P1 Q1 be the strip in OAL and P2 Q2 be the strip in A, B and L. Okay, now we have to consider that values over there. So at P1, so let it be P1, this is our P1 and Q1. So at P1, what is the value of x at P1? Because P1 lies on the y-axis, so the value of x will be 0. And at Q1, the value of x will be, Q1 lies on the parabola and equation of parabola was y is equal to x square, so the value of x will be root of y. Okay, and y varies from origin to the point this L over there. Okay, this is the variation of this. So that means y varies from 0 to 1 and x varies from 0 to root of y. That is the case for the first strip. Now let us consider the second strip. Let it be this one, P2 Q2. So at P2, so what will be the value at P2? The value of x will again 0 because it lie on the y-axis, and at Q2, Q2 point is lying on the straight line on the line x plus y is equal to 2, so x will be 2 minus of y. So x will be 2 minus of y, and y is varying from point L to the point B. So that means we are going to change the coordinate from 1 to 0. So that means y is varying from 1 to 2 and x is varying from 0 to 2 minus of y. Okay, so keep one thing in mind, never draw a horizontal strip where the point of intersection lies. Okay, we can't draw a straight line or we can't draw a strip. Okay, we can't consider a strip at the point of intersection. Okay, so don't draw any strip at the point AL. Okay, now so the given integral comes out as integral, surface integral over the region OAL, okay, in the function xy dx dy plus double integral over the region ABL xy dx and dy. Okay, so in area OAL we have, these are the limits. That means x is dependent, so it will be the innermost, and y is constant, so it will be the outermost. So 0 to 0 to root y into x into y into integrating with respect to x into dy plus, now in area ABL, in this part we have y from 1 to 2, and here we x 0 to 2 minus of y into xy dx and dy. Now we have to integrate both of the integrations with respect to x first of all. So 0 to 1 in y as it is, because it is a constant, and integral of x will be x square by 2 within the limits 0 to root of y into dy plus, then again 1 to 2 into y, integration of x will be x square by 2 within the limits 0 to 2 minus of y and dy. So that will be equal to half 0 to 1 y. Now we have to substitute root of y over this part, so it will be root of y whole square, that will be y minus of 0 into dy plus again half 1 to 2 y into 2 minus of y whole square, okay, dy. Now just opening the brackets over there, so it will be half integral 0 to 1 of y square dy plus half of 0 to 1 to 2 into, now we have to open the bracket over here, so this term, whole square of this term will be 4 plus y square minus of 4y. Okay, so we have to open the bracket, so it will be 4y plus y cube minus of 4y square into dy. So its integration will be 1 by 2, y square will be y cube by 3 within the limits 0 to 1 plus 1 by 2 4y square by 2 plus y 4 by 4 minus 4y cube by 3 within the limits 1 to 2. Okay, so 3 2s are 6, 1 by 6 will be there, upper limit minus lower limit plus 1 by 2 upper limit. Now if I substitute 2 over here, 2 square will be 4, 4 4s are 16, 16 by 2 will be 8 plus 2 raised to power 4, 2 2s are 4, 2s are 8, 2s are 16, 16 by 4 will be 4 minus 2 cube will be 8, 8 4s are 32, so 32 by 3. This is the upper limit minus of, now lower limit, so lower limit is y is equal to 1, so 4 into 1 4, 4 by 2 will be 2 plus 1 by 4 minus of 4 by 3. Okay, so after the complete solution over here, so what we get the result as 1 by 6 plus 8 plus 4 12, 12 by 2 that will be again 6 minus of 32 by 2 that will be 16 by 3 minus of, then 2 by 2 that will be 1, then it will be minus 1 by 8 minus 2 by 3, taking all the LCMs over there, so we get 24 as the LCM and we get a result of 9 over 24, that will be 3 over 8. That will be your answer for this question. I think so the question is clear to you. We'll take one more example for the same question, same category of type. Okay, so the second question over here is evaluate 0 to 1 x2 root of 2 minus of x square into x over root of x square plus y square into dx dy by changing the order of integration. Okay, so that means we have to change the limits over there, since the limits are in terms of x. Okay, that means they are the limits of y, and here it should be dy dx. Okay, so we have to change it in terms of dx dy. So here from the integral we get y from x to root of 2 minus of x square, and x will vary from 0 to 1. So now y is equal to x. What is this? It is a straight line. That will be question number 1 is a straight line passing through origin, okay, and the second one is y is equal to root of 2 minus of x square. This is your equation number 2. Squaring both sides, y square is equal to 2 minus of x square, or we can say that x square plus y square is equal to 2, which is a circle. Okay, so which is a circle with center at 0 0 and radius is equal to root of 2. So we will discuss this one now. Since the x is varying from 0 to 1, if x is varying from 0 to 1, that means we have to consider the first quadrant and fourth quadrant. Okay, and for this case, let the semicircle will be like this one. Okay, since the radius is root 2, so this value will be x is 0, y will be minus of root 2, and this value will be 0 and root 2 positive. Here we have get root 2 and 0. These are the radius of the circles, and O, that will be 0 and 0. Now the second one is straight line which is passing through the center, which is subtending an angle of 45 degree. So this is y is equal to x, and this is x square plus y square is equal to 2. Okay, now we need to we need which area? We need this one area over there. This area is being required. Okay, between the line and the circle, semicircle we can say. Okay, now since they have given the value of y is equal to xk, that means they have provided us with a vertical strip p and q. Okay, so to change the order of integration we need horizontal strip, but we can't consider a single horizontal strip which can touch the straight line and the circle simultaneously. Okay, so what we do, we divide the given area from the point of intersection. Okay, I'm again repeating, we can't take a strip, horizontal strip, from the point of intersection. So first of all we need to calculate the point of intersection. So let it be point A, this will be point B. Okay, so from equation number 1 and 2, from equation 1 and 2, what we get from equation 1 and 2, so y is equal to x and y is equal to this part, so that means x is equal to root of 2 minus of x square. Squaring both sides, x square is equal to 2 minus of x square, that means 2x square is equal to 2, so that means x square is equal to 1, that is x is equal to plus minus of 1. So that means since we are moving in the first quadrant right now, so it will be x will have a coordinate 1, since x is 1, so due to the value x equal to y, so y is also 1. Now drawing a perpendicular line over here, that will be L. On L, x coordinate will be 0 and y coordinate will be the same, because of the parallelism over there. So that means the coordinates of point A are 1 1. Okay, coordinates of O are known to us, coordinate of B are 0 and root 2. This one are the coordinates of B over there. So what we do, we divide the given area, required area, in two parts. Okay, so to change the order of integration, we divide the required area in two parts, OAL, and the second one will be ABL. ABL such that, so let P1 Q1 will be the strip in this case, such that P1 and Q1 be the horizontal strip in OAL and P2 Q2 be the horizontal strip in A, B and L. Okay, so at P1, what is the value of x at P1? Since P1 is lying on the y-axis, so that means this is point P1. So at point P1 the value of x will be 0, and at Q1 the value of x will be, now Q1 is lying on the straight and y is equal to x, so value of x will be equal to y. Therefore x is varying from 0 to y and y is varying from 0 to the point L. Okay, that is from 0 to 1. Y is varying from 0 to 1. Now at P2, at point P2, what is the value of x? Now P2 be the second horizontal strip in this region, P2 and Q2. Since P2 is lying on the y-axis, so value of x will be 0. Now at Q2, so Q2 is the point which is lying on the circle xk plus y square is equal to 2. So if I want to calculate, so x will be equal to 2 minus of y square root. Okay, we are going to take a positive sign. So x will be equal to 2 minus of y square root. So this implies that x is varying from 0 to 2 minus of y square root, and y is varying from the point L to point B, that is 1 to point root of 2. Okay, so the given area, the given integral is divided in two parts. First one will be OAL x over xk plus y square root into dx dy, plus the second will be ABL x over xk plus y square root into dx dy. Okay, so now coming to the area OAL, that is the first strip. Okay, in this case we have dependent limit as x, that it is varying from 0 to y, and y have a constant limit, so 0 to 1 for y and 0 to y for the limit of x. X over x square plus y square root into dx and then dy, plus again y is varying from 1 to root 2 and 0 to 2 minus of y square root into x over x square plus y square root into dx and dy. Now we have to integrate these two parts over there. Okay, so the integration of these two parts, first of all we have to integrate with respect to x. Okay, when we are integrating with respect to x, so we have to write it like this: 0 to 1, 0 to y, x into x square plus y square raised to minus 1 by 2 dx and dy. Now what is the integration of x plus y square? So it will be 2x, so I am going to multiply it by 2 and divide it by 2. Okay, same will be the property over here: 1 by root 2, then 0 to root of 2 minus of y square, x into x square plus y square raised to minus 1 by 2 dx and dy. Again, since it have a derivative 2x, so multiplying by 2 and dividing it by 2. Okay, so this function, now we are going to utilize the property of integral f dash x into f n x dx, that will be equal to f of n raised to plus 1 over n plus of 1. Okay, so 1 by 2, 0 to 1. Now it will be x square plus y square raised to minus 1 by 2 plus 1, that will be 1 by 2 over 1 by 2 within the limit 0 to y and dy. Same over here. Now 1 to root of 2 into x square plus y square raised to power 1 by 2 over 1 by 2 within the limits 0 to root of 2 minus of y square into dy. Okay, so this 1 by 2 and 1 by 2 cancel, this 1 by 2 and 1 by 2 cancel out, so we have 0 to 1. Now we have to substitute upper limit minus lower limit. So if I substitute x equal to y, so it will be y square plus y square 2y square, so it will be root of 2 y square minus lower limit 0. So if I substitute x square is equal to 0, so that means y square root, that will be y only into dy, plus now again we have integral 1 to root 2. If I substitute x square is equal to 2 minus of y square root, so it will be 2 minus of y square plus y square root. Okay, minus if I substitute x equal to 0, so it will be y square root, so y square root will be, that will be y into dy. So it will be 0 to 1, root 2 common, minus of 1 into y dy. Here we get minus y square plus y square cancel, so we get root of 2 again, so plus 1 to root 2, root of 2 minus of y and dy over there. Okay, so now integrating both of the terms, so since root 2 minus 1 is a constant, so I don't integrate it, so integral of y will be y square by 2 within the limit 0 to 1. Here we have root of 2, that means root 2y minus of y will have integral y square by 2 within the limit 1 to root 2. So it will be root 2 minus of 1 into 1 by 2 upper limit minus lower limit, plus now root 2 into root 2, that will be 2, minus root 2 square will be 2, 2 by 2 will be 1, upper limit minus lower limit, so it will be root 2 minus 1 by 2. Okay, so it will be root 2 minus 1 by 2 plus 2 minus of 1 will be 1 minus of root 2, then plus 1 by 2. So 1 by 2 plus 1, that will be 3 by 2, root 2 by 2 minus 1 by 2 plus 1 minus of root 2 plus 1 by 2. So these two part cancel out, root 2 by 2 minus of root 2. Okay, so on solving this equation, so what we get an LCM of 2 minus of root 2 by 2. So this will be your answer in this case. Okay, I think so the concept is clear to everyone, no doubt will be there. Okay, now we are going to consider one more question on the same topic, but here I am going to consider, instead of one, I am going to consider 3 steps over there. Okay, So the question over here is evaluate zero to 2a, then it is root of 2ax minus of x square to root of 2ax into v into dy and dx using change of order of integration. Okay, now here look at one thing. Here we don't have a function, so we can't evaluate. We have to only change the order of integration over here. Okay, now from the given integral, we have y from root of 2ax minus of x square to root of 2a minus of x, and x is varying from 0 to 2a. Now y is equal to root of 2ax minus of x square, so squaring both sides, so it will be x square, then we can say minus 2ax plus y square is equal to 0, or x minus of a whole square plus y square is equal to a square. Okay, that this method is by completing whole square, so which is the equation of circle with center at a0 and radius is a. Also y is equal to root of 2ax, that means y square is equal to 2ax. This is the second equation over there. Okay, so which is a parabola? Which type of parabola? It is a right hand parabola. Okay, so the diagram for this question will be like this one. We are going to take a circle. Okay, now circle is with the center at a0 and radius is a, so a is radius and diameter will be 2a, so 2a will be the diameter. So this will be the circle, and parabola is y square is equal to 2ax, that means like this one. Okay, so this is the parabola. Now this equation is y square is equal to 2ax, and the equation of this circle is x minus of a whole square plus y square is equal to a square. Now what is the second part? X equal to 0, that is the y-axis, and x equal to 2a. X equal to 2a is a straight line, okay, parallel to the y-axis and touching the circle at the diameter point. Okay, so this is x equal to 2a, so that means we are defined to this region, so this is the required region for us. Okay, this one. Now since they have given the y value, that means they have considered the vertical strip. Okay, so I draw a vertical strip according to the statement. So PQ will be the vertical strip. So according to the statement, we have been provided with a vertical strip, okay. Now to change the order of integration, we have to consider horizontal strip. Now how can I consider horizontal strip? The condition should be that the strip, both ends of the strip should touch the given curves. What are the given curves? This is the parabola, this is the circle, and this is the line. Okay, so we can't touch all of them at one point. Okay, so what we do, we divide the given area in three categories. So the categories will be like this one. I am dividing in three parts. This will be the point D. Okay, now first area, this will be the first area region, this will be the second region, and this will be the third region. Okay, three regions will be there. Now considering the first region, okay, so let P1 Q1 will be the strip in this one, P1 and q1. Okay, so first of all, what we have to do, we have to consider all the parts over there. So let us divide the given region or the required region in 3 parts. They are, this is O, which have coordinate 0 0. Okay, O, this is let it be A, coordinate is x is 2a and y is 0. Here we have a point D. Okay, here we have further y square is equal, here we have x equal to 2a. So if I substitute x equal to 2a on this part, so what will the result? We have y square is equal to 2a into 2a, 4a square. So y will be equal to 2a. So the coordinates of this point will be 2a and 2a. Okay, so OA, now I name it as point B. Okay, and what about the D? Here we have a radius at A, so its coordinate will be A and A. Okay, this will be the coordinates over there. Now in O, D, and here we need a point C also. The C will have coordinates A by 2 and A, and this point, let it be point E. This will have x coordinate as 2a and y coordinate is the height, that is the height of the circle, that is a. Okay, so we have to divide ODC, OCD and ADE, and the last one will be CEB. Okay, let P1 Q1 be the strip in the area CEB such that at P1, so at P1, what is the value of x? Since it is a parabola, so y square is equal to ax, so that means x will be y square by 2a. And at Q1, so value of x at Q1 is lying on the straight line. Okay, and this line is x equal to 2a, so it will be x is equal to 2a. Okay, now what about the y is varying from D. Okay, from or you can say from point E to point B. E have a coordinate a and B have a coordinate 2a, so y is varying from this part, so y square upon 2a to 2a, and y is varying from point A to 2a. That is the first case. Okay, now let P2 Q2 be the strip in OCD such that at P2, okay, let this will be the strip P2, this is Q2. Now at P2, what will be the value of x? X is again lying on the parabola, so x will be equal to y square by 2a, and at Q2 is lying on the circle. Okay, so from that what we get, if we have the equation of the circle as this one, x square minus of y square y whole square plus y square is equal to a square, this one, so that means x minus of a whole square is equal to a square minus of y square. So x minus of a is equal to plus minus root of a square minus of y square, so x will be equal to a plus minus root of a square minus of y square. So these will be the values over there. Okay, so we take a positive sign over there, so since it is lying in the positive quadrant, okay, and sorry, it is lying before the distance of a, so it will be a negative part. Okay, so x will be a minus root of a square minus of y square. This point will be a square minus a minus of a square minus of y square, and the second one where we take this point, so it will be a plus. Why? Because we are taking point a out after this one. Okay, so therefore x is varying from y square by 2a to a minus of root of a square minus of y square, and y is varying from O to the point height D. Okay, here 0 to a, y is varying from 0 to a. The third case, let P3 Q3 be the horizontal strip or strip in ADE, such that at P3, okay, now this will be your P3 and Q3. So at P3 x will have a value, positive value, okay, so it will be a plus root of a square minus of y square, and at Q3 x will be equal to 2a because it is lying on the line, okay. So therefore x is varying from a plus root of a square minus of y square root to 2a, and y is varying from point A to the point E. Here we have 0 to a, so it will vary from 0 to a, okay. So in the nutshell, what we get now, we get the given integral is equal to integral 0 to 2a y square by 2a, okay, to 2a into v dx dy, plus the next will be 0 to a, second range, y square upon 2a to a plus root of a square minus of y square v into dx and dy, plus the third integral 0 to a and then root of a square, sorry, a plus root of a square minus of y square to 2a into v into dx and dy. So this is the change of order of integration for this category of question over. Okay, I think so this question is again clear to you. So these were the questions which we have discussed. I think so rest of the question you can try. I can give a question to you from this content. Okay, you can try this question. So the question is, evaluate 0 to a by root 2 and y to root of a square minus of y square into log of x square plus y square into dx and dy where a is positive. Okay, now since x equal to y, that is a straight line, and x equal to this one, this is a circle, okay, and we are moving for y from 0, that means we have to work only the first quadrant over there. Okay, so I think so the concept is clear to you. If you like my concept, okay, then please share and like my video and subscribe my channel. Thank you, have a nice day, goodbye, take care.